Hello there, my name remains Oladapo and I welcome you to the Global Tutor virtual class. In this video class, I want to teach you an interesting topic in chemistry, and the topic is electronic configuration. How do we write the electronic configuration of an element? That is what I want to show you in this video. Now, before we start, for you to write electronic configuration, you need to know these orbitals. They are S, P, D, F. These are the four orbitals that you need to know for you to write the electronic configuration of an element. Now, the first thing you need to know is this. S orbital can accommodate a total of 2 electrons. P orbital can accommodate a total of 6 electrons. D orbital can accommodate a total of 10 electrons, and F orbital can accommodate a total of 14 electrons. Now, if you want to write the electronic configuration, usually we have electron to be signified as the power of the orbital. For instance, you have something like this: x to the power of 1, s to the power of 2, p to the power of 3, d to the power of 7. Now, what this power signifies is the number of electrons. So meaning, for the first one where I have x to the power of 1, it means 1 electron in s orbital, 2 electron in s orbital, 3 electron in p orbital, 7 electron in d orbitals. Now, another thing you need to know is the coefficients. We usually put coefficients for each of the orbital. For instance, if I have 1 here, I can have 2 here, I can have 2 here, I can have 4 here. Now, what each of these orbital coefficients rather signify is that the first one, s orbital, is in shell 1. This x orbital is in shell 2. This p orbital is in shell 2. This d orbital is in shell 4. So what am I saying? It means if I'm to write the electronic configuration, if let's say I'm using x orbital, what I have here means what? The number of shell. And what I have here means the number of electron. It means the number of electron. So the coefficients represent the number of shell and the power represents the number of electron. Now that you know that, let us move on. Now that you know that, let us move on. Now, another thing you need to know is this. Let's say we have our shells like this. This is shell 1. This is shell 2. This is shell 3. And this is shell 4. Some textbook will call it K shell, L shell, M shell, and N shell. Some will say 1, some will say 2, 3, and then 4. Now, the number of electrons in each of these shells is given by a formula 2n squared. The number of electrons in each of the shell is given as 2n squared. Now, it means if I'm talking about shell 1, I'm going to have 2 brackets 1 squared. 1 squared will give me 1. 1 times 2 will give me 2 electrons. Meaning in shell 1, the maximum electron we have there is 2. If I go to shell 2, I'm going to have 2 bracket 2 squared. 2 squared will give me 4. 4 times 2 will be 8, meaning the maximum number of electrons in shell 2 is 8. If I go to shell 3, I'm going to have 2 bracket 3 squared. 3 squared is 9. 9 times 2, meaning the maximum electron in shell 3 is 18. If I go to the fourth shell, it means I'm going to have 2 bracket 4 squared. 4 squared will be what? 16. 16 times 2 will be what? 32. Meaning the maximum electron in shell 4 is 32. Now that we know this, let us now apply this knowledge in writing the electronic configuration of the first 10 elements. Let us apply it in writing the electronic configuration of the first 10 elements. Now, to write the electronic configuration of the first 10 elements, let us start hydrogen. The electronic configuration will be 1s1, meaning shell 1, x orbital, 1 electron. The next element is helium, that is 1s2. Now remember, the maximum number of electrons in x orbital is 2. The maximum number of electrons in shell 1 is 2, meaning by the time you fill the second electron, x is filled, shell 1 is filled, meaning helium is a noble gas. That is another topic. But let us go on. Hydrogen, helium, then we have lithium. That will be 1s2, 2s1. Why is it so? Shell 1 is filled, so I need to go into shell 2. And each time I move into a new shell, the first orbital I see there is the s orbital. So for lithium, you have 1s2, 2x1. Then we have beryllium. Beryllium. So we have 1s2, 2s2. Then we have boron. That is 1s2, 2s2. Remember, the maximum number of electrons in x orbital is 2. So meaning by the time you fill the second electron, s orbital is filled. So we have 2p1. Then we go for carbon. We have 1x2, 2x2, 2p2. Then for nitrogen, we have 1x2, 2x2, 2p3. Then for oxygen, we have 1x2, 2x2, 2p4. Then we have for fluorine, 1s2, 2s2, 2p5. Then for neon, we have 1s2, 2s2, 2p6. So if you look at this, you will see that we have written the electronic configuration of the first 10 elements. Let us look at the electronic configuration again. The first one, hydrogen, 1x1. The second one, helium, 1s2. By the time we fill the second electron, shell 1 is filled, x orbital is filled. So if you are filling the third electron, it has to go into the second shell. And when you move into a new shell, the first orbital you see there is the s orbital. So you have 2x1. Then if you're filling for beryllium, you're going to have 1x2, 2x2. By the time you fill the second electron in x orbital, it is filled. So the new electron will go into the p orbital. So you have, for boron, you have 1s2, 2x2, 2p1. Then for carbon, you have 1x2, 2x2, 2p2. For nitrogen, you have 1x2, 2x2, 2p3. For oxygen, you have 1x2, 2x2, 2p4. Then for nitrogen, you have 1x2, 2x2, 2p3. For oxygen, you have 1x2, 2x2, 2p4. For fluorine, you have 1x2, 2x2, 2p5. And for neon, you have 1x2, 2x2, 2p6. Now, by the time we feel the sixth electron in p orbital, p is also filled. Now, in the second shell, 2, the number of electrons there now is 2 plus 6, which is 8. And remember, we said the maximum number of electrons that shell 2, the number of electrons that shell 2 can hold is 8 electrons. Meaning, when we feel the sixth electron in shell 2, we have filled the complete electron in shell 2, a total of 8. Meaning the 11th electron will be going into the third shell. And when you move into the third shell, the first orbital you will meet is the s orbital. I would like to stop in this video class, and I would like to leave you with an assignment. You can write the electronic configuration of element number 11 to element number 20. I'll pick it up from there in my next video class. But let me quickly introduce my book to you. I have a textbook that is available in PDF form. It is on calculations. Every calculation in O-level chemistry is in this book. It is about 170 pages. If you get this book, it will really help your study of chemistry. It is just 2,000 naira, and you can download it from this website, the Global tutors.com.ng. You can download it in this website, from this website, the globaltutors.com.ng. We will meet in my next video class. So long, success.